in rectangles. I know that looking at each other in rectangles maybe is a little anathema to kind of the outdoors life-giving processes of being together and growing and gardening. So the fact that you're here tonight, I appreciate that. Thank you. We're recording. Got it. Okay. So the format for tonight is going to be pretty brief. It's a Q&A mostly. I want to preface it with maybe a 10 or 15 minute little presentation on how I see compost tea and what it's about. I'm here as a commercial presenter. I run a business called Crooked Farmz, and we're entering our 4th season selling compost tea in Toronto to home gardeners and backyard farmers, some of the big urban agriculture growers in Toronto, and professional horticulturists. So obviously take everything you hear tonight with many grains of salt. This is something I believe in, but also something I do commercially as well. Okay. Slide. Okay, there we go. So I come to this, there's another quote that I forgot to put up here, but I come to this from what Grace Gershuni refers to as being a microbe farmer. So she says, contra kind of being a plant grower or somebody who raises animals in farming, that the compost producer and by extension the compost tea brewer is in the business of farming microbes. And I think that's kind of a nifty way of kind of expanding the domain of what we consider farming and what in an urban agriculture context, which is why I'm interested in in being here and the work of Toronto urban growers is this focus on urban agriculture specifically. Compost tea, I like this quote here from Eric Fisher that kind of gets us going. It's part of the repertoire open to the organic grower looking for an alternative to ecologically degenerate, toxic, and unsustainable practices of contemporary mainstream agriculture. Okay, so I post this here for 2 reasons. Number one, that we want to set ourselves up from the beginning as contra, industrial chemical agriculture of the 20th century. I think presumably everybody here has a sense that this has been ecologically devastating in a number of ways, and it's unsustainable. So we set ourselves up in contrast to that. Compost tea can offer us something that's not those things. At the same time, it's part of the repertoire. Okay, I'm not promising here the magic bullet or the solution to all agricultural contexts, all horticultural contexts. This isn't the thing that's going to be the one true solution. And we ought to be wary of, as things become more biological in nature, when you're at the garden center, be wary of anybody that can promise like we've isolated these 6 true microbes that are important. I think what we'll see over this presentation, and the more, if you're interested in this, the more you learn about it, is that the more diversity, the more biodiversity at the microbial level we can foster, the better we are. And so there's no kind of one microbe or one set of microbes. It's the most you can possibly come up with. And compost tea offers us one of those ways to increase that biodiversity. Again, coming to this, when we think about compost tea, like the why of compost tea, I've just recently read this book, Agroecology, Science and Politics by Peter Rossett and Miguel Altieri. And they talk about the principles of what constitutes a system that is self-sustaining, that is biodiverse, reduces external inputs, which is kind of what industrial agriculture is all about. How do we monetize chemical inputs into a system of growing, and in doing so, kind of disrupt the politics of a food system or the politics of a growing system. And they have 6: enhance the recycling of biomass with a view to optimizing organic matter and nutrient cycling over time. Number 2, strengthening the immune system. Number 3, providing the most favorable soil conditions for plant growth by enhancing soil biological activity. Number 4, minimize losses of energy, water, nutrients, and genetic resources. Number 5, diversify species and genetic resources in the agroecosystem over time at the field and landscape level. And number 6, enhance beneficial biological interactions and synergies, blah, 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 blah. Now, if we understand that compost tea is going to be this liquid drink of microbial life that is going into a soil, you can see where it ties into several of these agroecological principles. Particularly number 2, to strengthen the immune system of agricultural systems. And number 3, to enhance soil biological activity to produce favorable soil conditions for plant growth. Okay, this is the 2 places. And then further down, you see a number of references to biological synergy via genetic resources. And that's why I kind of referred on the last slide to how do we maximize the microbiology in a compost inoculant from which we can then brew a tea and contribute to that maximization of diversity. Okay, so here we come to sort of traditional notions of what you think of when you hear the word compost, hear the phrase compost tea. Number 1, people say, okay, it's the stuff, the liquid that leaks out of the bottom of your compost bin. Okay. And this is not compost tea. This is compost leachate. It's literally the liquid that can leach out if you have a pile that's too moist, or a compost system that's too moist, or a tumbler that's got too much liquid in it, it's going to leach out. And this leachate, you know, it can be useful, usefully applied to your plants. But we're going to hear reference to this. I'm going to use this term anaerobic. Anaerobic means that it's lacking oxygen, or it's lacking exposure to oxygen. And the microbes that proliferate in an anaerobic environment are not beneficial to our plants, mostly, for the most part. Okay, this is not an ironclad rule, but for the most part, anaerobic bacteria and microbes are not good. And so any kind of leachate that's been sitting in the bottom of a container for days, and then, you know, we get to it once a week or once every couple of weeks and kind of pour it out and pour it on our plants, probably it's not going to help much. It might hurt, it might not hurt, but that's a leachate. Then there's the more traditional, you know, where compost teas come from, and that's, you know, you take a shovel full of compost, you put it in the pantyhose or the pillowcase, and you soak it in a bucket for a few days. Maybe every now and again you take a stick and you would stir it around a little bit. We can refer to this as a compost soak, you know, kind of like a prototype of a compost tea. Again, we run into that problem if we're not stirring it often enough. We are not getting adequate oxygen into that pail, into that bucket in which our compost is soaking. And so the aerobic quality of that is compromised. Sometimes we can think of worm casting tea. Again, a kind of leachate. If we have a vermicomposting system and it's too wet and liquid leaches out the bottom, you know, we can think about that as a kind of compost tea. Again, has it been getting adequate oxygen? Do we get the leachate when it's fresh, or has it been sitting in the bottom of a tray for a week? It's got a little bit of a stink to it. Manure tea, same kind of idea. And then finally, the one that I'm interested in talking about, because this is what we sell, what is referred to as AACT, or actively aerobic compost tea. And what makes actively aerobic compost tea? Well, we are actually pumping oxygen into a brewing container. Okay, so rather than me once every 3 days taking a stick and stirring kind of a smelly old pail of compost in a liquid, which is fine, but it's not kind of, for lack of a better term, supercharging the potential of it. And with actively aerobic compost tea, we set up a technique by which oxygen is actively pumped into that system, and the aerobic microbes are able to flourish. Okay, what are some of the benefits of compost tea? Well, if we think about a system by which Oxygen is vigorously pumped into this system. The microbes that are in compost are able to come out into a solution. Okay. And this is kind of what the compost tea is all about, getting microbes into a solution so that the microbes can be applied to our soils. And we're, it's that kind of permaculture dictum: don't feed the plants, feed the soil. We are trying to get the microbes into the soil because it's the microbes. Sorry, I'll come to that in a sec, what exactly the microbes do. But what we want to do is we want to enhance the microbial life in the soil food web. Okay, if we want worms to come, and we know how beneficial worms are to a growing context, for them to come, we need to have bacteria, fungi, nematodes, protozoa there first. And the worms are going to be feeding on fungal matter, dead fungal bodies, as much as they're pulling down organic matter from the top of the soil. So we need to build the food web of a soil at the very base level. You can't bring a bunch of birds in and say, here birds, like make this soil food web come alive. It starts at the microbial level first. Number 2, soil aeration and water retention. What the bacteria and fungi in a compost tea do, and in a compost, but more specifically in a compost tea, because it works quicker, is it enables hyphae. So the fungi have little filaments and branches that reach out through the soil to access nutrients and water, to consume bacteria. When those fungi die, their bodies decompose, those little pore spaces are maintained, okay, at a microscopic level. And so you've got this network of little pore spaces that are able to turn sort of a more solid matter into something more sponge-like. Okay, as a result, air is able to pass through, water is able to be retained. That's number 1 and number 2. At the same time, the fungi are releasing substances called glomalin, and the glomalin is literally like a microscopic glue that will take your inorganic molecules of sand, silt, clay, and glue them together into aggregates. And so, when you felt a soil that's got a nice, kind of a nice aggregate quality to it, but at the same time will have some holding capacity, that is a result of these glues that the fungi are producing that, will allow binding, but at the same time will allow passage through. So it provides this kind of nice, neat little double trick where there's enough pore space for water to pass through in the case of, say, excess water, but also in the case of drought or low water, it has the sponge capacity to be able to retain water in the soil at the same time. In the absence of a thriving microbial life, this doesn't happen. Soil erodes, nutrients erode, it's all washing away, nothing's staying in place. Flooding is happening, and or water's draining away in a way that's taking the soil with it. Because compost tea is coming from compost, you will have some organic matter in that liquid as well. You will have some nutrient potential. You can add nutrient as desired to a tea and make it a liquid fertilizer at the same time as it's a microbial inoculant. It helps build fungal networks. And I'll come back in a couple of slides as to why fungi in particular are important microbes. But, we've referred to this potential already of the pore spaces and also the glomalin in terms of like literally agglomerating clods of soil together. When we introduce the biology, the biodiversity, the microbial diversity to a soil, it allows plants to be able to enact its own defense mechanisms. Plants can survive very well against many pests. Pests come into play when ecosystems are out of balance. And certainly in an urban context, we have ecosystems that are out of balance. We have soils that are out of balance. And we try, like we do with a lot of our medicine, we try and react to a symptom rather than look at kind of the underlying system at work. Plants are quite capable of defending themselves when the microbiology is there to form the synergies that they need to fight off, say, certain types of pest or disease. Carbon sequestration. Our soil not only should be an important resource for cycling water, but it should also be an important resource for sinking carbon. Our carbon should be in the soil. It should be in the bodies of microbial life, literally the carbon-based bodies of these microbes. And when we, in industrial agricultural contexts, when we till, when we apply all the asides, pesticides, fungicides, insecticides, when we leave soil bare, we are allowing, first of all, we're killing off all of the microbial life that's in the soil. And so what ends up happening is all that carbon comes out of the soil as carbon dioxide and becomes a huge greenhouse gas. What if we have a healthy soil that's cover cropped and the nutrients are continually being cycled, so that biology underground is continually being reinvigorated? All the carbon is now in the soil and it's being drawn down from the atmosphere, because of course that's how plants photosynthesize and get a lot of what they need is by pulling it out of the air. It's a regenerative agricultural practice. Okay, so that I'm gonna have to move my chat here to be able to see. With compost tea versus, say, compost, by putting it into the brewer, giving it oxygen, and the one thing I haven't talked about yet is we feed it sugar, we can increase the microbial count versus what you would get with simple compost. So it becomes kind of a supercharged drink. And I often refer to it at the market as being quite like kombucha. What kombucha can do for our gut flora by doing this kind of a brewing cycle with compost, we can do a comparable thing for our soils. Because it's liquid, it can go directly to the root zone. When you apply compost, it's either has to be tilled in or it's got to be surface mulch and take some time to break down. Whereas the liquid can be directly applied to the root zone. We can spray compost tea onto the leaves of plants, again, helping with pest defenses. And I personally have had great success with powdery mildew in certain contexts by spraying with compost tea and introducing the microbiology at the leaf level. It's inexpensive to produce versus a lot of the inputs you can get at a garden center or a feed store or whatever. And finally, I sell this in jars and buckets, and I'm lugging these things around all summer, so I think they're quite heavy. But actually somebody at the market said, look, I have an allotment garden on the other side of town. It's much easier for me to take 2 or 3 jars of this on the TTC than it is a bag of compost. And I said, oh, great, thank you. That's a nice tip. So, the concentrated nature of the tea can be quite helpful when you reconstitute it at a later point in time. So that kind of brings back the question, compost versus compost tea. And a lot of when you Google compost tea and you get these garden myths articles saying that compost tea is bunk, really when you tease through what the purported argument is, it's like, well, does compost tea really do anything that compost doesn't? It's not that compost tea doesn't work. It's not that there isn't science to back it up. It's that you could accomplish the same things by composting. And maybe that's the case in certain ways. I pointed out on the previous slide some ways that it's not like composting. Composting is always a recommended practice. You will get microbes and organic matter to build up a humus layer in your soil. So it's a good thing. However, what you can also get, is a buildup of salts, a buildup of salinity overall, depending on what and where you're sourcing your compost from. You can get a lot of contaminants. And, I don't know how many people are aware of this, but in Ontario, with industrially produced compost, We have government standards that say you are allowed to have this much contamination legally in your compost before you sell it to the public. Now, home composting, of course, you're in control or in charge in a different way. But compost tea, you're not going to be pouring shards of plastic and glass onto your garden. Compost tea, because it is essentially water-based, will give you the microbes, not so much the organic matter. You're going to get more microbes though, and you're going to get to the root zone immediately. So I mentioned this already in the last slide. Finally, not only is it lighter in weight to kind of bring across town on the TTC from the last slide, but for those of us, again, in an urban context who are growing in containers and using kind of light, fluffy potting soil, compost tea is lighter in weight, lighter in density. And so it's nice to water in microbes in with your kind of more inert potting soil to introduce that microbiology without collapsing the fluffiness, say, that you might get from that soil when you pot up. Okay, next slide. Compost tea, it scales in a way that's nice, that compost doesn't necessarily. When we compost in our vermicompost or under the kitchen sink, we compost in our backyard, or if we go to Miller Composting, where they're doing this big industrial operation, or the City of Toronto anaerobic facilities, it really changes the nature of the compost that's produced and the quality of what you get. With compost tea, it's less so the case. I mean, really, it means more inoculant and more water, but the essential process is the same, and that is vigorous oxygen. We'll go to the next. Oh, sorry. I forgot to put that slide in. I'm sorry. Essentially, in all three of these cases, what we're looking at, if we're to abstract the principle, is to take an inoculant of compost, to put it in water, to pump it vigorously with oxygen. And that pumping vigorously with oxygen accomplishes two things. Number one, it gives the oxygen that aerobic bacteria and fungi need to feed on and multiply. And number two, it has a physical effect where it rips the microbes away from fragments of compost that are in your inoculant. Okay. And then finally, there's a sugar that you're feeding, which in many cases, or most cases, is molasses. And that can be scaled from the 5-gallon bucket right up to on the left, you see a 2,000 gallon, what's called an Ericus brewer that's used on large scale farms. But the same principles can hold true at the farm level as it does in the backyard. What we're trying to do with the compost tea is to put the fungi, the bacteria, the protozoa, and the nematodes right in with the organic matter that's already in soil, with the mulch that's breaking down into soil. And this is going to form symbiotic partnerships with the plant roots. The plant roots don't access nutrient from the soil on their own. They send out chemical signals called root exudates to the fungi and bacteria, who essentially perform like a fetching system where they bring the nutrient to the plant roots in return for the sugars that are contained in these root exudates. And that's kind of where my microbiology ends. It's obviously more sophisticated than that, but the idea is that there are these things called root exudates that are a chemical signaling system that plants and microbial life form symbioses. And what's the point of doing all this? Well, different kinds of plants thrive in different kinds of soil. Okay, when you have bare dirt, what happens when you have a plot of bare dirt? Weeds are going to start to grow. Weeds are nature's way of pioneering a cover for the soil. The nature does not want the soil to be bare, and so weeds begin to grow in this place. what are they indicating? They're indicating a very highly bacterial environment or context in which they grow. Over time, as we can shift that that threshold or ratio of fungi to bacteria, and if you recall what I mentioned at the beginning of what do the fungi actually do? Well, they're creating soil aggregates, they're creating porosity in the soil, they're binding the soil. And the more we can make our soil fungal through the use of compost and the use of compost tea, but also through things like cover cropping and other sort of like farming strategies, we start to move the ratio into areas where different kinds of plants thrive. Right up to, you know, if we get to the old growth forest is highly fungally dominated. The ratio, it's like a 10,000 to 1 fungal to bacterial ratio in the soil of a forest. And not surprisingly, this is where we go when we want to go on our mushroom walks, right? We see all the different fungi and the diversity of fruiting fungal mycelial networks in a forest. We don't see them in an open field. And this is because the soil changes. As the soil changes, different types of plants thrive. So the kinds of plants you're growing are somewhere in the middle there, and compost tea helps us push the succession of that soil into a more fungal range or you know, a more equivalent fungal to bacterial range, and you'll find that those plants are going to start to thrive. At Crooked Farmz, you know, more and more I'm realizing that it's not so much the technique of the brewing that matters as it is the quality of the diversity of the inoculant. And so, you know, Crooked Farmz is a backyard. It started out as a backyard. It's my backyard. And one of the things that I'm interested in is what kind of a high quality compost can we produce in limited urban footprints? You know, getting quality inoculant in terms of microbiology is a real challenge. Getting it enough of it. Yes, we can do a vermicomposter under our kitchen sink, but that's going to maybe feed a few houseplants. It's not going to feed a whole garden of vegetables. We can go to the industrial compost producers, but that compost is going to give you organic matter and nutrient levels that have been verified, but a certain amount of contamination and almost zero microbial life tested under a microscope. So this is kind of my goal, is how do we create as much of a rich inoculant as possible, diversity. And so you'll see here, I have different composting techniques on the go in 6, you know, Earth Machine style composters, as well as some vermicomposting, large vermicomposting totes. And by cycling worm castings and more fungal and hot composting, more bacterial bins together, my aim is to get something that's as diverse as possible in terms of microbiology, which then goes into the brewing operations for my sales later on. And of course, I'm applying all of this on my own spaces. I have a fairly shady space in the backyard, but over the years that I've been doing this, observationally to see how the biodiversity has changed in the last 5 years in terms of earthworms arriving several years ago, butterflies in increasing number, but more butterfly species, other insect species. Just it's anecdotal, I know, but at the same time, to see it as gardeners, you know, it's our power of observation. And I mentioned this in the land acknowledgement at the outset, that observational quality, I think, is something that's really important. And I've seen the changes over 6 years here by reintroducing soil microbiology. And then for me, that ends up going into subscriptions, 1 liter jars that go to subscribers around Toronto. They're available at farmers markets. They're available in larger quantities to urban agriculture growers and horticulturists, professional landscapers. And that's my story. So I know I rifled through a lot there. and it was kind of even a lot for me, and I kind of know this stuff already. So I hope to open this up to a Q&A where I can hopefully either elaborate some more on what I went through, or if you have other questions that I can help out with. And I think Rhonda might facilitate anything that was happening in